Hey guys, welcome to my YouTube channel. Professor LJ here, your tutor in mathematics and physics. So today we are going to talk about organic chemistry. This is a continuation of a past video where we were talking about introduction into organic chemistry, where we were talking about the homologous series, the functional groups, and just the general stuff around the entire topic. So today we are gonna get a little bit deeper into details, but what I want us to notice first is how we actually name those organic compounds. That's what we're gonna focus on today. IUPAC naming, that's what it's called, which is the universal naming. You're in grade 12 now. You should know that you're about to do real chemistry. So the universal naming of organic compounds. So guys, let's get into it. So the very first one, it's the alkanes. But before we continue and get deeper into alkanes, I want us to focus on the naming here. So basically, let's look at it like this. So if you look at the condensed structural formula here, you're gonna actually see that, okay, if we have one carbon, we're gonna have meth at the end, at the beginning. There's meth. If we have 2 carbons, we're gonna have eth. If we have 3 carbons, that's prop. If we have 4 carbons, that's gonna be bute. And then if we have 5 carbons, that's gonna be pent. Then that's how we do it for all the hydrocarbons. Actually, it's actually how we do it. So basically, all the hydrocarbons, it's meth, eth, prop. What differs in the hydrocarbons is the suffix, the ending of it. For example, for alkanes, we end with ane, and then when we call them, if it has 1 carbon, we say methane. If it has 2 carbons, we say ethane. If it has 3 carbons, we say propane. If it's alkenes, how do we do it? If it's alkenes, we're gonna go with the same way which we actually go about with alkanes. It's methane, right? But now it's alkenes, so that means the suffix has to differ. It's gonna end in ene, so it's gonna be we don't have methane actually, because alkenes, for alkenes to we have to have double bond between adjacent carbons, right? So it starts at ethene. It's ethene, propene, butene, etc., etc. Also for alkynes, the counting is still the same. 1 carbon atom, it's meth. 2 carbon atoms, it's eth. 3 carbon atoms, it's prop. 4 carbon atoms, it's bute. 5 carbon atoms, it's pent. And 6 carbon atoms, it's hex. 7 hept, 8 oct, etc., etc. But now the suffix is going to differ for alkenes. For alkenes, we are going to actually have YNE as our suffix. Actually going to have YNE as our suffix. If you look at, we have ANE right here because this is alkanes. But actually for alkynes, we're going to have YNE as our suffix, which means we're going to have ethyl, ethine, propyne, butane, pentine, etc., etc. So that's how these things get named. Now let's get into, okay, this is another example of alkanes. Methane, this is the structural formula. There's 1 carbon, methane. There's 2 carbons, ethane. 3 carbons, propane. 4 carbons, butane. Wonderful. Let's get into how we name the haloalkanes. So this is our table for haloalkanes. Now we said haloalkanes is actually an addition of a halogen on an alkane. So basically we're saying that we remove a hydrogen atom, and replace it with a we remove a hydrogen and replace it with a halogen, and then we get a haloalkane. So basically that's what happens in a haloalkane. So in a haloalkane, it's named exactly the same way that an alkane is named, except that there has to be some respect given to that halogen. So now, in naming haloalkanes, we actually look at which carbon is the halogen attached to. For example, the first example, it's chloromethane, because the halogen is attached to the first carbon, which is the only carbon that exists in this example. It's chloromethane. If you look at the third example, it's 1-iodopropane. Now we have 3 carbons. Now the carbon that has iodine attached to it is actually the first carbon. So basically we're gonna have 1, as we are actually saying where is this thing situated in this propane. It's attached to the first carbon, so it's gonna be 1-iodopropane. For the other example, 2-chloropropane, chlorine is attached to the second carbon atom, so we have to say 2-chloropropane, etc., etc. That's just how you go about in naming haloalkanes, right? Let's keep going. Now, this thing of meth, eth, prop, but ends within the 4th homologous series. When we go to the other homologous series, we don't say meth, we say methan, ethan, propan, butan, etc., etc., etc. For example, if we were to name an aldehyde now, we have to only add al at the end of the name, and then we're gonna get, for example, C2 chain length, we're gonna get ethanal. If we have 3 carbon atoms, we're gonna get propanal. We have 4 carbon atoms, we get butanal. See, this is the one for aldehydes, butanal. So this is how you also differentiate and see that, okay, this one is an aldehyde when it ends with al, butanal. That's how you go about naming these things. For ketones, we said that moving on from aldehydes to the other homologous series, we are just going to start with propan, butan, methan, etc., etc., right? So if we're going to ketones, we're going to add O-N-E, right? So it's going to be ethanone, propanone, butanone, O-N-E at the end of it. So basically that's just how you go about in naming these things, right? So let's get here. These are examples of alcohols. We said that we count the carbon atoms and then we add the suffix. Now the suffix for alcohols is OL, all alcohols, OL. So basically the first one, we have 2 carbon atoms, right? That's ethan, which means when naming that compound, we're gonna have to say that is ethanol. The second one, we have 3 carbon atoms. When naming that alcohol, we're gonna say that is propanol. The third one, we have 4 carbon atoms. When naming that alcohol, we're gonna have to say that it's butanol. That's how you go about naming this stuff. All right, let's keep going to the other ones. These ones are carboxylic acids. Now, when you name carboxylic acids, it follows the same procedures as the alcohols, the aldehydes, and the ketones in terms of the number of carbon atoms. But then now, what differs is the suffix. For example, if we were to name the first carboxylic acid, the one right above here, we would say we have 3 carbons, right? That's propan. So that means this is going to be a propanoic acid. If we're naming the one with 4 carbon atoms, which is the second example, we're going to have to say it's butanoic acid. That's how you name them. Let's keep going. This is an ester. Okay, an ester kind of differs a little bit because an ester is actually a combination of a carboxylic acid and an alcohol. So when we name them, it's a little bit different, right? The group that comes from alcohols, we change it and then we add YL at the end of it. For example, here we have 2 carbon atoms and then we have 2 carbon atoms for the carboxylic acid. So here if we were to name this one, we're going to say this is ethyl ethanoate. Ethyl ethanoate. That's how we would name this one. So the suffix for esters, it's actually OATE, OATE, ethanoate, ethyl ethanoate. That's how it goes around. Yeah, that's all that's all the homologous series and how you go about naming them. Now, in a straight chain, for example, let's talk about this one, the third alcohol. This is a straight chain. A group may be added to this one. Like a group can be added to any organic compound, right? So when a group is added, we also have to give a bit of respect to that given group. Now, what is mostly important here is to note that, okay, when a group is added, we have to actually count the carbon atoms of the added group, and then when we actually decide on the number of atoms of which what are we going to name that group as. For example, if a group with one carbon atom is added, we know that that's a methyl group. If 2 carbon atoms are added to a group, we know that's a ethyl group. If 3 carbon atoms, it's going to be a propyl group, etc., etc. Now, the most very important thing that you have to note when you are working with this part of chemistry is that a group cannot be added on the first carbon atom. All right. So if the last carbon atom appears to be curved, it's still the straight chain. A group can never be added to the first or the last carbon atom. So that is very, very important to actually note. Another thing important to note, when you are naming, also having groups involved, you actually have to know that it's going to be a little bit difficult, but not much difficult. It's going to be a little bit different because you have to, there's a way that you count with, which is very, very important and will guide you throughout your IUPAC naming. The greatest rule in IUPAC naming is that you start counting closer to the functional group, but then we'll cover that in the next video. Thank you so much, guys, for watching this video. Please subscribe and hit that like button. The next video is dropping soon.